So we have spent the last couple of slides talking about what a least squared regression line is, how to find it if we have data, how to find it if we have summary statistics. Now I want to know, how do I use that equation to predict? Because remember that hat means that it's predicted. And what exactly does each part of the least squared regression line mean? So let's start by predicting using our least squared regression line. So we had a fast food example earlier, and it was our first example where we had the least squared regression line equation in the correct format, and that described the data in the graph to the right. And my question is, what could I predict the fat content of a Tender Crisp sandwich at Burger King to be if it contained 31 grams of protein? And how do I do that? Well, I'm going to take my equation, which we determined earlier, and I'm just going to replace protein with 31. Then I'm just going to do the math. Again, order of operations says we're going to multiply first before we add, and then I get 36.61. So what that tells me is, based on my equation, I can expect a Tender Crisp sandwich to have about 36.61 grams of fat. So again, I can write that out in words, and you might be asked to do so, but that is what it means, is I would expect 36.61 grams of fat. What it does not tell me is how many grams of fat a Tender Crisp sandwich actually has. So we will revisit this example a little bit later, but it just tells us what we predict, and that's why we use the fat hat. Other things I might ask you about your least squared regression line is to talk to me about what the slope means, or what the y-intercept means. So in this case, I'm looking at the slope. We hopefully all know that the slope here is the 0.91, and if you're ever unsure, remember, if it's written in the correct format, it's always the second value. But even if it's not written in the correct format, we know it's always the one being multiplied by x. So to interpret what it means, this part is not necessary. This part I use for students who have a hard time explaining what slope is. And I know that slope is 0.91, and I also know that slope is the change in y over the change in x. And so all I've done is taken that and written it with the 0.91 y over the change in 1x, because that's what we're dealing with. And then I replaced y with fat and x with protein. And so my determination, or my interpretation of the slope, is that this model suggests that for each additional gram of protein, so for each additional whatever your x is goes here in a fast food item, the fat content, this is the y of that item, will increase by 0.91 grams. This is the slope. So that is how I interpreted the slope. For every additional x, y is increasing or decreasing by whatever the value of the slope is. Similarly, if I want to interpret the intercept, or y-intercept, of our least squared regression line, remember that our y-intercept is this one here that is not being multiplied by anything else, it's just being added. And I want to interpret, what does that mean? So again, I don't need to see this part, because this is just what we use to understand. But remember, the y-intercept is 0 on the x-axis and whatever the value is of the intercept on the y-axis. And so in this case, that's 0, 8.4. So when you interpret it, it's best to interpret it talking about the fact that there's 0 of something. So the model predicts that a fast food item that contains no protein, so this is my 0x's, will contain 8.4 grams of fat. This is my y-intercept and y label. So here's one for you to try. It's interpreting the slope, the intercept, and also making a prediction from Atlanta to New Orleans. So please press pause, try all 3 questions, then press play to see how you did. So first, the question is, how would I interpret the y-intercept? Remember, the value not being multiplied by x is our y-intercept, and I think about it in terms of 0, 177.21. So how would I interpret the y-intercept? I would say a plane that's going 0 x's, which is 0 miles, distance in miles, would have a fare of 177.21, or a plane that travels 0 miles from Atlanta cost $177.21. Now, does this one really make sense in context? I would say does not make sense in context. I could also say, I could also say that this might just be the base cost or the beginning cost, the starting point at which all flights would then increase from there. How would I interpret the slope? Remember that the slope value is 0.079, and that's 0.079 y's over 1x, which is x is distance. And so when I talk about it, I would say for each additional 1 distance, well, what's distance measured in? Miles. I would expect the fare, because it's positive, to increase, and again, this is in dollars. So how would I interpret it? I would say for each additional 1 mile traveled, I predict the fare to increase by basically 7.9 cents, or $0.079. Last one, traveling from Atlanta to New Orleans costs $199 and covers 419 miles. How much would we expect that fare to be based on our model? So don't just say, well, obviously it's $199. Remember that that is the actual value. My question is, what would we predict? What's our prediction? What would we expect to have happen? And in that case, I need to take this formula and I need to replace distance with 419. So here I've replaced distance with 419. I've done the calculations in my calculator, remembering that order of operations has this operation happening first, and I get 210.31. So we would expect our flight to New Orleans to cost $210.31. In actuality, it cost $199, which means it's going to have a negative residual.